Hello and welcome to another MUNSCI physics video. Today we will be looking at Newton's laws of motion. Newton's laws of motion are three statements describing the relation between the forces acting on a body and the motion of the body, first formulated by English physicist and mathematician Isaac Newton, which are the foundation of classical mechanics. As Newton defines, there are three laws of motion. An object in a state of rest or in a state of constant velocity will remain in this state unless it is acted upon by an unbalanced force. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. And for every action, there is an equal and opposite reaction. Newton's first law of motion states that an object in a state of rest or in a state of constant velocity will remain in this state unless it is acted upon by an unbalanced force. It basically describes that a body that is moving at a constant velocity or a body that is at rest, which means it has a velocity of 0 meters per second, will continue to remain in the same velocity forever unless a force from outside of the body system acts on it to change either the magnitude of the velocity or the direction. The state in which the body is in constant velocity is known as translational equilibrium. For example, a ball rolling on a flat ground at a velocity of 1 meter per second should continue to grow forever with a velocity of 1 meter per second. But however, you might have realized that this is not the case. This is because of the action of various forces on the Earth, such as friction and air resistance, which apply a force opposite to the direction of movement, thus changing the body's state of motion. But when you try to push a wall or retreat, it may not move. This is because the wall experiences friction that is equal to the force applied, and thus the two forces are cancelled and the wall does not move. These forces that cancel out are called balanced forces, and thus the Newton's first law of motion defines the forces to be unbalanced. Let us move on to Newton's second law of motion. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Newton initially defined the second law relating the acceleration of an object in regards to its change in momentum and thus derived the formula of force. Thus, the derivation of Newton's second law gives us the formula force is equal to mass times acceleration, and the unit of force being newtons, named after the man who discovered it. 1 newton is defined as the amount of force required to give a 1 kg mass an acceleration of 1 meter per second squared. Let us try an example using this formula. The net thrust exerted by a car is equal to 1000 newtons. If the weight of the car is 5000 newtons, calculate the acceleration of the car when g is equal to 10 meter per second squared. You can pause the video and try to solve the question. Let me walk you through the solution. So the force is equal to 1000 newtons and the weight of the object is 5000 newtons. And since the weight of the object is given by the formula W is equal to mg, we can get that the mass of the object is equal to W over g, which is 5000 over 10, which is 500 kilograms. Therefore, the acceleration of the object is force over mass, which is 1000 over 500, which is equal to 2 meter per second squared. Newton's third law of motion states that for every action, there is an equal and opposite reaction. A better way to say this is when two objects interact, they apply forces to one another that are equal in magnitude and opposite in direction. Let me explain this with an example. When you walk or run, you push the ground backwards and the ground exerts a force equal to the magnitude of the force you exerted on the ground, but opposite in direction, thus propelling you forwards. From Newton's second law, we can say that the acceleration of an object is inversely proportional to the mass of the object. Thus, the Earth experiences negligible acceleration, whereas the person who's running experiences a greater acceleration, even though the force applied on them is the same. This is called the law of inertia.